So very quickly, we're going to be solving a churn problem. And now this churn problem is for this particular data set of concern is for a bank. Now, it's not compulsory. You have to be in the financial institution before you want to predict if your customers are going to churn or not. So churn is you getting to leverage artificial intelligence to decide if a customer is either going to cancel their subscription, or a customer is going to become inactive, or a customer is going to delete your app. Now, it's very important we get to understand which customers are most likely going to churn, and we can even predict when they're most likely going to churn. But right now we are concerned with which customer is likely going to churn. Now, after you've decided, the end point of this is so management can get to understand, okay, if these customers are going to churn, what can we do to ensure they don't churn? What other services, what extra juice, what extra ice can we bring on their cream, whatever ice can we bring on their cake, so they don't churn. Now, looking at this data set, we can see the roll number, customer ID, surname, credit score, geography, gender, age, tenure, balance, down to exited. Now, it's not compulsory you have a data set with this same number of column or with this exact number of columns. So the key thing we need here is the target variable, which is exited or churn, or if the customer left. So irrespective of your business category or whatever sector you fall in, all you just need to do is to export your data set based on columns that you think, from your knowledge of your industry, columns you feel is going to be impacting on either the customer is going to churn or not. So yours could be number of minutes or hours spent on the mobile application, number of clicks spent on each time he opened the application, how long he used your mobile application, when did he register, when did he leave. So it depends on the institution. For an e-commerce, you want to check how long also he took for a buyout process, how long it took him to pay, was there any friction, how long he spent on each page. So the thing about data gathering, you want to be versed with data gathering. Try to understand, capture each point, each behavior of your customer, and so by the time you have all of these things in one place, and you bring in the column exited, did he leave, did he not leave? And here, 0 means he did not leave, he stayed, and 1 means he exited. So yes, so this is the data set that we are going to be working on. Then it's very important to ensure that your data set is balanced. So especially the target variable that you're trying to predict for. So if you have, for instance, we have 10,000 records of various individuals for this particular data set. So imagine having 10,000 records, and you have 9,000 records all exited. So the model is going to be biased to exited customers. So at every point in time, you want to ensure you have a balanced data set. And so let's quickly hop down, creating a project, and we'll begin to build the models. Now, so navigate down to project, create a project, bank, customer churn prediction, and then create the project. Now, again on Autogon AI, when building machine learning models, there are two different tools you can use on Autogon platform. There's the Studio Wizard and there's Studio. So Studio Wizard is an auto ML platform where you can build powerful machine learning models in just 3 steps. Whereas for Studio is Autogon no code AI IDE. So integration development environment, integrated development environment. So drag and drop for an IDE. So it's just beautiful. Drag and drop AI IDE, very beautiful. So here we have full custom power to data preprocessing steps and the machine learning algorithm or the deep learning network that we're wanting to build off of the data sets. Whereas on Studio Wizard, we allow Autogon Auto ML work on our data set and decide the best algorithm to use and come up with the best accuracy. So for this bank customer churn prediction problem we're solving, we're going to start first with Studio Wizard. We'll build our model, create our pipeline, inference our model. Then we're going to now go hop onto the Studio environment where we then build similar models and use other type of models as well, and for same data sets. So we'll click on the Studio Wizard and bank customer churn prediction. We'll select the CSV dataset. We allow this to load up. We give this some seconds to load. And beautiful, it has loaded up. Now we can see that age is of high importance for these data sets, same as balance and same as number of products. So age, balance, number of products are of high importance, and exited and is an active customer. So yes, so this analysis just shows you high level which of your dataset columns are of most importance, of significant value to whatever you're trying to decide off of these datasets. Now exited, so we can see exited is a categorical variable, and when we are building models for a categorical variable, we are going to be using classification. Good. So now we go to the next step. Training type, we select classification. Target variable, we select exited, and model name, and we'll call it churn, and we'll click on the train. So we'll give this some seconds to build up. So our model has been built, and our model has an accuracy of 0.82, meaning 82% accuracy. A simple way to also calculate this accuracy is looking at this confusion matrix and sum these two values divided by the sum of the total values. Okay, so very quickly, let us make attempt to test out our model, or we can look at the feature of importance also. The surname, the age, number of products, balance. So each of these things coming together is active. So each of these, actually the name and the age and the number of product, and so each of these things comes together to play a significant value as to deciding if the customer churns or not. Okay, so we click on prediction, and let's quickly generate a test data set. So we can either try out a new observation, a new customer, and we enter the customer details and get the value if the customer churns or not, or we check out from an existing data set. So right here I opened the data set that was used to build the model, and then let's copy one of the observations, copy this particular observation, and so we can't place this directly on Autogon portal, so we have to generate a data set off of this. So one way to do this on Autogon AI is to come on quick predict, select the model, select the project, the model, create data set, and paste, select one dimension, and voila, a URL has been created for us. We can visualize this, and this is what we just generated without the exited. So we copied from here. This is because we are trying to use all of these other observations to predict if the customer is going to churn or not. Okay, so now that we have our test this dataset URL, we can enter the test dataset URL here and click on predict. And beautiful, we scroll and we can see there's a prediction label of 1, so meaning this customer is actually going to churn. And here is the prediction accuracy, and the prediction accuracy is 1.0, so meaning this particular customer is going to churn. So we can even navigate down here on models, so just in case we have built more than one model off of our data set, and then you can see this model has an 82% accuracy. We can always see the confusion matrix, feature of importance, and the last item we actually predicted. So let's test out another observation. So we can pick this particular observation, and let's create out a data set off of this, copy the data set, and enter this new data set, and we click on predict. And yes, we have the model predicting that this person is not going to exit. And beautiful, yes, this person is not going to exit. So you can even try out new observation of a new customer who is going to come in, so this model is actually performant with an 82% accuracy. Let's generate another test data set, copy it, copy it, and insert this test data set right here, and we predict, and great, and the model says this other person is not going to exit, and right here the customer didn't exit. Okay, so we've tested out our model with a couple of observations, and our model is actually performant. But yes, our model has an accuracy of 0.82%, 0.82, which is actually 82%. So for you to inference your model via an API, you have to create a pipeline. So we will call this Churn pipeline, and we create the pipeline, and we can always copy the pipeline ID. And so hence pipeline has been created. We can test out our pipeline from this quick predict session. Click on this, the project, the model, and yes, we have an input link, which is this that we've generated initially. We can come directly here and insert the input link, and we run the model, select the pipeline, churn pipeline, and we predict. And yes, we got this customer will actually exit, so the customer is actually going to churn out. So yes, beautiful. So we've been able to create a model leveraging Autogon Auto ML platform. So now we are going to navigate down to Autogon Studio and create create models also leveraging Autogon Studio off from this same data set. I've showed you how to inference your model, and it's not compulsory inference your model using the quick predict. You can also inference your model via the API. So let's open Autogon Studio. Open Autogon Studio. Good. And we'll drag in our data input block. So data input block is the start of any project that you're building. You have to bring in your data set. So the data input block, we'll need to input our data sets. So we can come in from this data set menu. We're working on bank customer churn prediction. Enter the URL and we run this. Now I'll show you the advantage of Studio now. So looking at this data set, row number, so this like the serial number on the database. We need to knock this guy out. Customer ID, no, I don't want this model hinged on the customer ID. We'll knock this guy out. And surname, yes, we're gonna knock this guy out. So we're gonna have a model that is flexible and not hinge on any particular individual here. So to do this, we need to drag in the drop column. We need to remove. Let's look at the columns. We need to remove 0, 1, 2. So we need to, so this is index 0, index 1, and index 2. We need to remove index 0, 1, 2. Don't forget where we are dropping the columns on the data set. And if we've splitted, then we can drop on X or on Y, but we're dropping on the data set. So let's give this some time to run. And successful. So we've been able to drop those columns. Now the next thing is, if you observe our data set, oh yes, this is for the churned items. So if you observe our data set, you'll see that these are text data and our model doesn't understand this. So we would want to pre-process this 2 columns, and there are 2 ways to go about this. It's either two ways to go about this on Autogon. Is either we use the automated data preprocessing. So I advise you go through the route of automated data preprocessing. If you have multiple columns, you can then preprocess multiple columns in your data sets. But because we just have 2 columns to preprocess, I'll just bring in data encoding, because we need to encode those particular columns. And now let's now specify what columns we need to encode. We need to encode index column index 1 and column index 2. but we have to do it differently. So column index 1 happens to be country, column index 2 happens to be male or female. So this is like a binary classification, either a male or a female, but this is not a binary classification. So the mode of encoding this is going to be different from the mode of encoding this. So for this, we're going to be using label encoding, but for this, we're going to be using one-hot encoding. So label encoding on the main dataset variable, pass through, let's specify, so 0, 1, 2, index 2, and we'll call this index 2 happens to be gender underscore width, and we'll run this. Beautiful. So we're trying to, now we've been able to encode index 2, so you can now see 0, 0, 0, 0, 1, 0, 1. Yeah, so and if you look at the 0, you already see that it encoded 0 as female, male, female. Yeah, so now it's time to encode the country. That's index 1. So let's look at this to be sure. Yes, index 1. So we're dragging another data encoding again, and this time around we pass in index 1. So like I said, we're not going to use label encoding, we're going to use a one-hot encoding, and for the data set, pass through index 1, and we'll call this country underscore width. Build this. So why we need to save this is because we are going to build a pipeline, so it's not compulsory if you're not building a pipeline, but if you are building a pipeline, it is compulsory, so you can leverage this saved width already. Now if we look at the data set again, we will see that the country has been encoded. So you see 1, 0, 0, 0, 0, 1, 1, 0, 0. So let's look at what it's attributing 1 to. So 1 is France, 0, 0, 1 Spain, 1, 0, 0 France again, and there's Germany, and so on. Good. So now if you look at our data set, we now have a good enough data set, but we are yet to split the data set, feature sample it into X and Y, and so we need to split it into X and Y first, then split it into X train and Y train. Then we can now go ahead to feature scale it. So good. I would reduce this. Then we'll bring in feature sampling. We need feature sampling, and feature sampling, we can enter colon, comma, colon, -1, colon, comma, -1. So now this is called slicing. So it's a way to sort through matrix dataset in data science. So this is rows and columns. So column are the rows. This particular symbol here means all the rows, then this means all the columns except the last column, whereas this is saying all the rows for the last column. Now on Autogon AI is not compulsory, so you can read more on slicing from our documentation. On Autogon AI is not compulsory you use slicing to split your matrix, but it's just a faster way to go about it. You can enter the column indexes, 0, 1, 2, 3, like that, and enter the last column index here, and it still works. Good. So now we've entered our boundaries. Let's then run the feature sampling. So we can go look at it. Now we have our X value and Y value, and you see the X value is without the exited, and now we see the Y value has the exited. This is beautiful. So the next thing now we need to do is to split our data into train and test. So we look for data split. So data split, and we assign 0.2%, meaning 20% to the test data set and 80% to the train data set. So it's like a standard. You can do 25% to test, and if you have a very small data size, you can even use 0.1 to test. Okay, so random state, we'll leave it at 0, and we split our data sets into train and test. And now you can see, if you look at the X value, we had 10,000, but if you look at X value, we have 10,000. If you look at X train, we have 8,000. So this is because 80% has been assigned to train, and if you look at X test, we have 2,000. 20% has been assigned to test. Okay, so looking at our X train, our data set is almost good, but we're not done yet. So if you notice, column 7, column 11, and column 0, they have high values, and we would need to scale each of these columns, so our model is not going to be biased to those columns. So we scale the entire thing. So we're going to drag in feature scaling. So let me structure this so we can have some space. We've just dragged in feature scaling, and feature scaling will specify the X train and we specify the X test, and we're going to use a min max scaler this time around, and colon comma means we're scaling every single thing, ones and zeros, and feature scale underscore weight, so we can easily reference it when we are building our pipelines. So if we look at our X train, we'll see that it has been scaled. Those high columns has been scaled, and if we look at our X test, we'll see that those high columns has been scaled as well, which is beautiful. So now we can now go ahead with building our models. So I want to try out random forest. So now what kind of model are we building? First of all, now if you look at the Y value is either zeros or 1, meaning we are building a classification model. Yes, so we're building a classification model because it's a categorical variable of exited or did not exit. So we're going to bring in random forest classification. So random forest has a regression, but ensure you specify random forest classification. We'll also drag random forest classification predict and random forest classification metrics. We'll check out random forest. Now, why do I like to bring in random forest or XGBoost? There are several other classification algorithms. This is because these are ensemble models, and ensemble models most times tend to come up with more accurate results, but not all the time. So there's also some more classification algorithm like logistic regression Yes, logistic regression is a classification algorithm. Good. So we specify a name, so we'll call this random forex classification, and we can use the default genie there, and we run this, and this is done running. We would use the model gotten from here to predict our X test. Remember, we splitted our data set into train and test, and this is the X test after feature scaling. So we enter the name of the model, default. Now when you specify default channel here, you are instructing the system to use this model here, and also when you leave here blank, you're instructing the system to use X test. So let's run this. And beautiful. So we've been able to predict the X test, and then we have our values. But let's quickly check out metrics so we want to check out the accuracy. So what we are comparing here is the Y true versus the Y pred. So meaning we're comparing this. So this X test, the Y value for it is the Y test. So what we're doing in metrics is we're comparing what the model predicted should be the Y test values, and so we're comparing the Y test. Sometimes you can see it as Y true versus the Y pred. So I can't wait to see the accuracy of this model. And good, we have a 0.84 which is 84%. So a random forex classification came up with an 84%, which is a good one, very good one. So another thing again we could do is we can play with other machine learning algorithms or deep learning algorithm, designing a neural network structure. But for the sake of this course, I'm going to keep it simple. We're going to build an automated machine learning model, run an automated machine learning algorithm off of this same data set. So we would drag this particular block, then drag the metrics of this, and we'll drag the predict of this, connect it to feature scaling, and we'll connect all of this together. Now with this alone we can go live, but what we are wanting to do, go live meaning like production ready, but what we're wanting to do, we're wanting to see how we can try out more other algorithms and get the one with the highest accuracy. So I'm going to try a 120 seconds and runtime of 20, and I call this automated machine learning CP. And yeah, you can use any name here. So let's give this some time to run. Okay, this block is done running. Let's look at the sprint statistics, and we can see that 15 algorithms ran, and we have an accuracy score of 0.86. good. And so we can enter this model name here, default, to predict, and we'll also enter it here while we wait for this guy to run. We can also see from the leaderboard here, the extra trees had the highest accuracy, ranked the highest. Okay, so this block is done predicting. So it's done predicting X test, and now we have a Y pred value. So metrics is going to be comparing the Y test value and the Y pred value. So that's y true and y pred, and it measures the deviation and comes up with an accuracy value. So let's give this some seconds. Brilliant. So we called we called the white pred twice. Sorry, we're supposed to have metrics, not spread. Okay, enter the model name, then we run this. Okay, then brilliant. We have 0.84, that's 84% accuracy, which is beautiful. Okay, so without taking much time, so we can see the random forest here, 0.84, and extra trees here also has a 0.84. So let's try out deep learning. So we're going to be trying automated deep learning. So we're going to drag in automated auto-structured data init, or auto-structured data evaluate, and auto deep learning predict. So we connect it from the feature scaling, and we connect this init to evaluate, and we connect the evaluate to predict. Brilliant. So max trials, we'll keep our max trials as 10, and we run this. For evaluate batch size, we can keep our batch size to as 10, and before the evaluate was to call the train, after the init you have the evaluate, after the evaluate the train. Yes, good. Train first, then the evaluate. So here we define the model name, auto structured data classification. We just call model, and we give epoch of 20. So here we can max trial 10. We'll keep the batch size same, and so let's give this guy some seconds to run. Okay, so beautiful. This block is done running. We are now going to call batch size of 10 to evaluate this particular model, and so let's open this, and good, we have 0.82. So apparently the random forest has the maximum accuracy of 0.84, and 0.84, the random forest has the highest accuracy. Good. So now that we have we've gotten the best model to this has 0.848, and this has 0.4. okay, so this guy has the highest. So now that we've gotten this, we can then proceed to build up a pipeline. So building a pipeline is very simple. You need to take note of the data preprocessing steps that you've taken and the model of your choice. So here we called in a drop column on column index 012. We also called in a data encoding, and we saved the weight on 2 index 2, another data encoding on index 1. So to do this simply, I could just open a new page and open same project, just so we can compare it together. Open Studio to have another instance of this running, and here we create the pipeline. So we can call this pipeline underscore ID, and we'll create this. And so the first thing we called there was a drop column on 012. I'm going to call it drop column here on 0, 1, 2. Now the next thing we called here again was a data encoding on index 2, and just for gender, I'm going to call a data encoding here, point to this index 2, and it's for gender. So the next thing we called here again was another data encoding block, index 1, and the weight is country. Another data encoding and index 1, and the weight is country. And that thing again we're going to do here is feature sampling. Now feature sampling, we can leave this one. Yes, we'll leave this one. We're going to call the next one, we're going to call is feature scaling. So feature scaling, we're going to call it for all boundaries, and save name of this. So feature scaling, okay, for all boundaries, and feature scaling of this. Then we can then go ahead to run the save. So give this some seconds. Okay, now we have this saved. One more thing we need to add is the model. I forgot to add it initially. Select the model, and the model with the highest accuracy was this guy, AMLCP, and select the ALMCP, and we can run save again. So it's important I capture all my live process of getting every single thing done. So you see, no one is above making mistakes. Beautiful. So now we can then switch back to our studio environment, and if we visualize the main data sets, or you can see we are done a couple of processes on these main data sets. Now the beautiful thing, I'll show you the beautiful thing about pipeline. Remember, on the pipeline we dropped these 3 because on the pre-processing we dropped it, and we pre-processed every single thing, and we're going to be predicting for this. So let's go ahead to pick this guy. Okay, I think we have yes, we have a data set here. Yes, we have a data set here. So we can go ahead to call this predict, select pipeline, pass in the pipeline ID, and pass in that particular data set, and run our predict. And the pipeline is going to drop those 3 initial columns if we get it right. pre-process the entire data set and give us our prediction. And you can see it came out with a success. And what's the prediction? 1. And this is beautiful. So you can see so the pipeline works. So now we can go down to the quick predict region. Quick predict region, and we select the data set, and the data set happens to be with Churn, and we created this model. This was the high performance model from the studio environment. Input link, we can enter the same link, if we select the pipeline, so this Churn pipeline, we created it from Studio Wizard. So we select this pipeline and we predict, and good, we have the one. And if you want to see the pipeline logs, you can look at it, and you'll see drop column, what we designed on the pipeline side, drop column applied to column 0, 1, 2, and it dropped those respective columns, and one hot encoding happened next, and another one hot encoding happened, and hot encoding. Then can I see this as the feature scaling on all the boundaries before model predict. So you can see this is what was inferenced to the model exactly. So beautiful. We have our pipeline fully functional, and we can also inference our model from our API, as simple as we have. Okay, let's test some more predictions using this model. Okay, let's create for this. Let's create a test data set out of this, and at dimension 1, copy this, input, replace the link here, and we run this for pipeline ID, and we got 0, and yeah, 1. Good. So the model did not get this accurately. Let's try this. So that's where the margin of it's 4%, so there is a 16% imperfection with its prediction. So dimension 1, and if we copy the data set, input link, and we run the model, select the pipeline ID, and run it, and this came out with 1, and this is 0. Good. So we can also do the same thing. We can also do this same data set. We run it as against pipeline, and we select Churn pipeline. This is what we got from Studio Wizard, and we got a 0. So meaning the Studio Wizard model predicted this correctly. Let's try one more prediction. So good thing we are inferencing 2 models, which makes a whole lot of sense. Copy this and change the URL here, and we start first by inferencing pipeline ID. The model we built from Studio, and we got a 0 and it's a 1 here, and we inference again, and we inference the Churn pipeline, the one we built off of Studio, and we got a 0 and it's a 1 here. So both models prediction did not accurately get this particular one. So we can just try one more example. We'll click on create data sets, we input this, select dimension 1, copy our data sets, and we change the data set input link here. We first try out pipeline ID, and this got a 0, and we'll try Studio Wizard model, and it's got a 0. And what is the correct one? 0. So both models actually predicted this record correctly. So yeah, so now we have our both pipelines working. We can hover back to our project, open our bank customer churn, copy the pipeline ID, can navigate to Postman, replace this flow ID with a pipeline ID, and I can also replace this data set here with my data set. And if I hit this, good. So we've gotten our prediction results and it's a 1. Beautiful. So yes, you can inference your churn models for new observations. So a customer who just registers newly, you can then predict if this customer is going to churn or not. Even for existing customers, you can also do a prediction of those existing customers, inferencing into the model to find out if they are going to churn or not based off of their behavior. So this is how you can make data-driven decisions seamlessly. And yes, you can always generate code snippets off of Postman and use for your code. As simple as that. Thank you guys.